No, thank you.
You're not even taking notes.
One second. Then, okay, so what I want us to write down are the key, I guess key points, I would call them. I don't know if they're really points. Yeah, we'll just call them key points. And they're going to be all of the y coordinates. I guess I should say key y coordinates. Nope. So their key y coordinates are going to be 0, 1, 0, -1, and 0. We want to memorize these for the sine curve. Because that's what happens here with the curve. We start at 0, then we go up, then we hit 0 again, go down, then back up to 0.
Kaylee. Wasco's not here.
Okay. Aaron, you could go to the bathroom now. Do you guys want to investigate for the cosine? All right, let's investigate for cosine. So I want us to sketch y equals the cosine of theta.
X over R. Bro, I can't hear you. First one's 1.
Okay, so similar to the sine, our x-axis will be our thetas, and our thetas will be 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to use the unit circle to help me evaluate. And our key points on the unit circle are 1, 0. Nope, if you have them memorized in your head, you do not. And now I want to evaluate the cosine of theta at the given angle measurements. So first thing I want to do is find the cosine of 0 pi. Well, do we all agree cosine is x over r? So at 0 pi, my x-coordinate is 1, and my radius is 1. So at 0 pi, my value is 1. All right, now I want us to find the cosine of pi over 2. What is the cosine of pi over 2?
0.
0. Cosine of pi. Do we all agree that's -1? Cosine of 3 pi over 2? 0. And the cosine of 2 pi is back up at 1. So this looks something like that. So I want you to memorize the motion for the sine, and I want you to memorize the motion for the cosine, the movement of it, how the graph looks, because a cosine will always look like some version of this. The sine will always look like some version of the one above. So I want to memorize key y values for cosine. And our key y values that we want to memorize will be 1, 0, -1, 0, 1. Oliver, stop sleeping. We done copying? Okay, now there's different parts of cosine and sine curves that we want to talk about. The first new vocab word is going to be amplitude. New vocab word. Okay, so the amplitude is going to be the height from the center line to a peak or dip. The next vocab word is going to be period. And a period is going to be the length of the smallest interval that contains exactly one copy of the repeating pattern. Okay, now we're going to talk about formulas to memorize. So for a traditional sine curve, we're going to have y equals a times the sine of b times the quantity of x minus h plus k.
For spacing purposes, are we going to have a tan graph?
No, not. We're going to just focus on sine and cosine, and then after we quiz, then we'll do other graphs. So we're only focusing on sine and cosine right now. And that's for sine. For cosine, we're going to have y equals a times the cosine of b times the quantity of x minus h plus k. For both of these, the amplitude is going to be found by taking the absolute value of a, and this essentially determines the height of the graph. To find the period, and remember the period is going to be how long it takes for one full copy to be made, so one full curve to be made without repetition, just one, is going to be 2 pi divided by the absolute value of b. And this determines how quickly a full graph will show. Okay, quarter period is going to be the period divided by 4. And what this represents is going to determine our x coordinates. And the last thing I'm going to write under formulas to memorize are our key points or key values. So key values for sine of theta, we said we're going to be 0, 1, 0, -1, 0. And the key values for cosine theta will be the point 1, 0, -1, 0, 1. And this is everything you need to memorize for the whole unit. This is everything you need to memorize. And now I'll show you how we apply these.
What is a quarter period again?
A quarter period determines on our x-axis how we're going to label the x-axis, so our x-coordinates. Miss you. We ready to do a problem? So what I want us to do Here are our sample problems. I want us to graph 3 times the sine of x, or sorry, y equals the 3 times the sine of x. So this is a pretty simple one, but they're not always going to be this simple. So what I usually like to do is write down the sort of formula for this. A times the sine of b times the quantity of x minus h plus k. So based on this, do we all agree that our a is 3? And what about b? What's b? If there's no number there, it's a 1 in front of the x. So my a is 3, my b is 1. Now what we want to do is find the amplitude. And that's going to be the absolute value of a. So in this scenario, it's going to be the absolute value of 3, which is 3. The next thing we want to do is find our period. And the period is going to be 2 pi divided by the absolute value of b. So this is going to be 2 pi divided by the absolute value of 1. Well, isn't the absolute value of 1 just 1? So this is just 2 pi. Now we want to find the quarter period. And to find the quarter period, what we do is we take the period, and what do we get for the period? 2 pi, and then we just divide it by 4. I'm going to write this out, sorry. So we are 2 pi divided by 4, which is a half pi.
Would pi over 2 also work, or is that something?
Yep, pi over 2 works too. Half pi, pi over 2, same thing. Sure, like there?
Yeah.
We have it written down or still copying? Is he? That's okay, I'll wait for her to catch up. Okay, now can we go?
Yeah.
Okay, so let's start graphing, or start our process of graphing. So now this quarter period that we found here, this determines the interval that we're going to write down on the x-axis. So the origin will always be 0 pi. But then the quarter period tells us what our next interval will be. So it's going to go from 0 pi to pi over 2. Or a half pi. And then the next one, I'm going to add another half pi. So what's a half pi plus another half pi? Just pi, right? 2 pi over 2, just pi. And now I'm going to take that 2 pi over 2, and what am I going to add to it? Another half pi. So what's 2 pi over 2 plus 1 pi over 2? 3 half pi. Pi. So this one, this pi was a half pi plus another half pi, right? Which is 2 pi over 2, which is just pi. So now we're going to take the 3 over 2 pi, and what am I going to add to it this time? Another half pi, which is going to give us 4 pi over 2, which is just 2 pi. Yeah. No, the quarter period will change. Not so much for this class. When I step it up on Monday, it will change then. Right, so now we have our x-axis labeled. Now we want to find our y-coordinates. To find the y-coordinates, what we're going to do is remember y equals, what was this problem? I don't remember. 3 times the sine of x. So I want to list the sine values, sine of theta values that we said to memorize. So the sine of theta values that we said to memorize are the key points 0, 1, 0, -1, 0. All right, so this is where it's a little weird. Aaron, you and me? So now what we're going to do, this represents the sine of theta by itself, or sine of x by itself. But what have I done to the sine of theta, or the sine of x? What is this 3? Multiply by 3. That 3, and then the sine of theta, or the sine of x, means multiply by 3. So what I'm going to do is I'm going to take all of these key values, and I'm going to now multiply each of them by 3. So 3 times 0 is 0. 3 times 1 is 3. 3 times 0 is 0. 3 times -1 is a -3. And 3 times 0 again is 0. And these represent the y-coordinates. So now we go and plot. I'm going to say 3 is up here to really exaggerate. -3 is down here. Okay, so the first point is 0. So at 0 pi, it's 0. And then at a half pi, I'm going all the way up to what? 3. And then at pi, I'm back down to 0. At 3 over 2 pi, I'm all the way down to -3. And then at 2 pi, I'm back up at 0. And now we trace the curve. So what has happened to the sine curve versus the original one that we did on the unit circle?
It moved up and down 3.
It got taller, right? And good. Go back. What was my amplitude? Wasn't my amplitude 3? And look at that. It went up 3. All the way 3. And down 3. Peak and dip. Yeah. Okay, next one. Sure. I know. I wanted to show you. Oh, well. Okay.
I'm really worried about it.
It's because we waited so long for Aaron.
Yeah, that's not his fault. I think just because of him, you know, because of what he did, we shouldn't even get to do anymore. You should punch us. Don't want us to see.
That was a good try, though. Okay, do we all agree our A is -2? A is -2. What's B? Nope. 1. B is right here. That's 1, since there's nothing there. All right, so our amplitude is going to be the absolute value of A, which in this scenario will be the absolute value of -2, which gives us 2. So our peak and dip is 2 units from the center. And then we want the period. The period, if you guys remember, is going to be 2 pi over the absolute value of B. Do we all agree this is just going to be 2 pi? Now we want the quarter period, which I'm going to put as QP. To find the quarter period, we're going to take the period and divide by 4. So this is going to be 2 pi over 4, which is just a half pi. I'm going to put KP for key points. And the key points for the sine curve, remember, are 0, 1, 0, -1, 0. I'll let you all catch up. Okay, but now we're doing a whole bunch of things to our parent graph curve. What we're doing is we're taking all these key points and multiplying it by -2. But then what am I doing? Adding 4. So we have to do both of those to the key points. So we're going to start with the multiplication. So I'm going to multiply by -2. And when I multiply by -2, I get 0, -2, 0, +2, 0. But I'm not done because I also have to do what? So now I'm going to take the new coordinates and I'm going to add 4 to each one of them. So 0 plus 4 is 4. 4 plus a -2 is a +2. 0 plus 4 is 4. 4 plus 2 is 6. 4 plus 0 is 4. These are my new y coordinates. And now we graph.
If we just graph, why do we have to write it?
Yeah, because on the test I'm going to ask for all of it. Okay, so what determines my x-coordinates?
The angle of the unit circle.
The quarter period. So what is the quarter period? Isn't it pi over 2? So that means each interval is going to add a pi over 2. So we're going to say 0, and then pi over 2, and then what?
1.
Pi. And then
3 over 2 pi.
3 over 2 pi, and then
2 pi.
2 pi. We're almost done. We're almost done. Bear with me. And now we're going to represent our x-coordinates right here, which will be positive 4, 2, 4, 6, and then back down to 2. And now, guys, when you connect this, oh, 4, sorry. So what has happened? Doesn't the original sine curve look like this? What happened? It's the inverse. It got reflected, right? The movement got reflected. So this is the inverse. And what made it the inverse?
The negative.
The negative a. The negative a made it the inverse. Okay, now we are done. Oh, it is warm in here.